Okay. Hi, good morning everyone. Today we'll be going through the topic on practical electricity, but we'll be going through the structured part. So with this worksheet, I would want you let's turn to page which one is it? Let's turn to page 15, alright? I think yeah, 15. Alright, so from here we're going to use this lesson to go through as many questions as we can, right? So that you'll be able to learn and write down what you know, and if you've done this, then you can just check the answer and see whether is it correct or wrong. Okay, alright. So without further ado, let's start. Alright, so section B. Now we have a flashlight bulb connected to a 3-volt battery, right? Negligible internal resistance. The ammeter shows a reading of 0.7 ampere. So battery, right? Ammeter, light bulb. Okay, so let us write down the quantity that we know. Okay, ammeter shows a reading of 0.7 ampere, so meaning the current will be equals to 0.70 ampere. What else is given? The total voltage and the total current. Okay, the total voltage is given by 3.0 volts. So what is the electrical power used by the bulb? Now we'll make use of the formula. Power P is equals to V times I, the potential difference times current. So potential difference is 3 volts, current 0.70. So the power would be 2.1. Unit for power is watts, right? So number 1. Okay, number 2. Electric iron with heating element of resistance. So the R is 60 ohm connected to voltage 240 volts. Calculate the electrical power produced in the heating element. So first I will present you two methods. Method 1. Method 1, we are going to make use of the basic idea where you've got P equals to VI and V equals to IR, right? So we'll make use of this to find the I, alright? So this one is the safest, or the one that uses less brain power, because you will remember less formula if you go by this method. So first, V equals to IR, right? Then second, you connect this to power equals to VI. You've got the voltage, but you don't have the current. So you need V equals to IR to find the current. So V, I don't know, but R. Right, so 60. So 60 times what will give you 240? 60 times 4 will give you 240. So the current is 4 ampere. So last but not least, power is 240 times 4. Right? 240 times 4. So I will get a 960 watts over here. Right? So that's method 1. Now method 2. Method 2 will use the fact of the very convenient formula that if you are a bit hardworking, you can remember the formula. So you can use the formula where power based on voltage and R, right, is actually V square over R. Right? So V square, we have 240 square over R divided by 60. So 240 square divided by 60 will give me 960 watts. Alright, so two methods. Method 2 looks easier, but it means you also need to remember more formulas, right? Okay, so B. Let's find the amount of electrical energy consumed when we operate the iron for 20 minutes. So if they never specify any unit, we're going to go with the SI unit. So meaning this 20 minutes is our time, 20 minutes, right? So let's convert this to SI unit, seconds. So this is actually equals to 20 times 60 seconds, right? Okay, so how do we find energy? So energy is equals to power times time, or power is equals to energy over time, correct? So energy is the power times time. So what we can rewrite, I will just rewrite it like this, right? Energy is equals to power times time. Important formula. So power that we find earlier, power in part 1, 960 watts. the time is 20 times 60. Alright, so here we have, okay, here we're going to have 1152000 energy in joules. Let us convert this to 3 SF, so this will be 115, then the rest 0, right? 3 SF, 3 important numbers, right? So this is for 2A and 2B. Alright, next let's look at 2013 N level paper 2. Alright, so here the diagram shows the wiring of a 3-pin mains plug. What is the gap over here in X? What is this gap here? Now this gap is actually the fuse, right? The component is put here is fuse. Explain the purpose of this component. Now, so the purpose of this component is to break the circuit in event of an excessive current. There is an excessive current. Okay. Alright. Okay, so that is sorry, that is part 16. Okay, now let me find some resources first so that I don't teach the wrong thing. Here, no. Okay, let's look at this then. Okay, so for part B, okay, now let's look at this now. For part B, now the plug is attached to a small electric immersion heater. Okay, so what does thing immersion mean? Immersion comes from the English word immerse, meaning need to soak one. So imagine this heater, you soak into the water and it will heat up the liquid there. Okay, so this is what we call an immersion heater. Alright, so the elements of the immersion heater is enclosed inside a metal tube, and the thermal energy is generated. So heat is generated when current passes through the heat element. So it heats up the water in the cup. Alright, now and notice that this we have a 3-pin plug, right? So over here, now explain why the metal tube of the immersion heater is connected to the earth wire of the plug. So here, why is it connected to earth wire? We have to refer to the concept of the earth wire itself. Okay, we have to refer to the concept of the earth wire itself. So here you can write here that okay, so you can write this as, so the earth wire will prevent the user from getting electrocuted, right? And when will this happen? When the live wire, or more like not when, if, not, yeah, if the live wire, right, touches the metal case, touches the metal parts, there's no case, so touches the metal parts. Okay, alright, so that's part 1. Part 2, the immersion heater is placed in a cup of cold water and switched on. The water at the top of the cup becomes hotter than the water at the bottom. So this process is our convection process. Right, convection process. Now explanation, you have the whole story. So the heated water, okay, at the bottom becomes less dense and rises. Right, then the second story is the cool water, the cooler part of the water, right, which is denser, right, because it is denser, it will sink to replace the hot water. Right, so this process repeats and convection current is formed, right? But for this case we don't need this, we just need to explain why the hot water goes up, cold water goes down, right? Number 3, right, the heat immersion heater is rated 0.5 kilowatts, right? So 0.5 kilowatts. So what quantity is that? The quantity is actually your power. 0.5 kilowatt. Let's expand this out to your SI unit. So this would be 0.5. Wait, it's kilowatt hour. So we just leave it there. Right. Very quick glance. You just take a look there. Kilowatt hour. Right. So it takes 1 minute to boil the water in the cup. Right. Okay. So 1 minute for 1 cup. So the time for 1 cup is 1 minute. Right. Okay, then another thing is also 6 cups of waters are boiled. So calculate the total cost using the immersion heater. Alright, before we find the cost, alright, because it is a cost per energy. So before that, we need to look for energy. Right, so energy, okay, the formula energy is equals to power times time. Power must be in kilowatts, right? Time must be in hours. So when you combine, you get kilowatt hours, right? So what are you going to do is, alright, so we've got power in kilowatt, 0.5 kilowatt, right? Times the time. Time for 1 minute, correct? Time for 1 minute. So 1 minute is equals to how many hours? So actually 1 divided by 61 over 60 hours. So time in hours is 1 over 60. Okay, last but not least, how many cups of water times 6 cups? Okay, so we are going to just use a calculator to calculate. So 0.5 times 6 times 1 over 60 times 6. Any other thing? We have 0.05 kilowatt hours. Okay, 0.05 kilowatt hours. Then last but not least, the cost, right? For 1 kilowatt hour is 25 cents. So this will be 25 times 0.05. So this will be okay. So this will be 1.25 cents to boil 6 cups. Right, quite cheap, huh? 1.25 cents to boil 6 cups. Right, so far so good. We're just making use of the formula and we're just multiplying by how many cups. Okay. Alright, so that is that question there. Right, 2014 N-level paper 2. Alright, let's look at this. Now the heating element, so of an electric iron is connected to a 240 volt main supply. So here the voltage is 240 volts. Right, then we have our 3 wires coming from the main supply connected to the electric iron. Right, so what are we going to do? The important thing is to determine where is the live, where is the neutral, and where will our earth wire be. Okay, so number 1, live wire. So live wire is where the current comes in, but to prevent from any tragedy, we need a fuse connected to the live wire. So which wire XYZ, right? Which one has a fuse there? Here. So meaning X will be the live wire. Okay. Next, which wire connects the apparatus and it will flow out? Y or Z? Now let's look at where Y is connected. Y is connected to the appliance at this point, and this square part, right, if you look at the label, is the metal casing. So is it connected to the thing that you power up itself? No. Right, so Y, if it's connected to the metal casing, right, since it's connected to a metal casing, so it's connected to the earth wire. Right, so earth wire always connect to metal casing. Next one, Z is the one that connects to the heating element. So Z is our neutral wire. So current flow in from X, come out from Z if nothing happened. Okay, right, so which wire must be connected to earth? Y. Right, name the component labeled W and state the function. W up there mentioned is a fuse. So what is the function of a fuse? Must remember it is to break the circuit or to isolate the equipment, right, when there is an excessive current. Right, so if you do a lot of puzzle paper, right, you can actually see that this question keep repeating already. Right, so this model is found on the electric iron. We have this, so 240 volts, so the voltage is 240 volts. The 50 hertz, what does 50 hertz means? This actually is the frequency, 50 hertz. Right, so let's put it here, 50 hertz. Alright, so this is the heating element. Okay, then last but not least, 200 watts. So this is power equals to 200 watts. Okay, so first calculate the current in the electric iron. So we use P equals to VI, use the formula. Right, so 2000 equals to 240 times I. So divide by 240. We will have 8 and 1/3. So this will be 8.33 ampere. Right, 8.33 ampere. Now Singapore Power, right, can, alright, so Singapore Power charges 30 cents for each kilowatt hours. Calculate the cost of using the iron for 20 minutes. So here will be the cost, correct, for 1 kilowatt hour. Then we have our 20 minutes. So time 20 minutes, right? Because we are looking for kilowatt hour, just change to hours. So we got 20 minutes divided by 60 hours. Okay, then what about the power? Power is in 2000 watts. So let's change this to kilowatts, right? So 2000 watt is literally 2 kilowatts. Alright, then anything else? Okay, so far don't have. So in order to find the cost, we need to find the energy use. So energy is equals to power times time. Power is 2 kilowatt. Time is 20 over 60 hours. So 2 times 20 over 60, this is actually equals to 0.667 kilowatt hours. Alright, or more like, actually I should use the exact amount. Okay, let me put, it should be a 2/3 kilowatt hours. So the cost is actually this amount of kilowatt hours times the price, so times 30 cents. Right, so here we will get 2/3 of this will be 20 cents. Right, 20 cents. Okay, so the important skill here is to convert. Okay, I think last one, right? Last one, 2017. The table below shows the maximum power rating of an appliance that can be safely connected to the potential 240 volt main supply using a wire of the given diameter. So from a trend, if you notice, as the diameter increase, the maximum power rating also increase. So how does it affect? You just state, so very easy. As the diameter of the wire increase, alright, if the diameter increase, the maximum power rating also increase. Do we need to explain? No, because this question, it is only to state. Right, state meaning we just say only, don't need to explain. Right, state. Okay. Alright, B. What is the thinness of the wire? Alright, you can use to connect 2750 watt electric kettle to the main supply. So we have to use the maximum power rating above the 2750 watt. Otherwise, you cannot reach the fullest potential. So you have to use the one above. So the one above is this one, 3120. So that will be the thinnest wire, right? So that will be 1.25 millimeter. Right, so in other way, you can think of it as, if you don't know what is it talking about, just if you're looking for the minimum, and minimum must be the minimum one, the smallest one, greater than 2750, correct? It cannot be the minimum one less than 2750. Otherwise it doesn't make sense, because the minimum one is just like that, right? So if you think of it that way, then you can apply it nicely. part 2 explain what will happen if a thinner than this one will go. So meaning if the operating at higher power means you got more current, the wire will burn. So the wire will have too much current and will break. So this is very, very dangerous, right? It will melt and break. Okay, so I guess that's all for this worksheet. Now you may continue to go ahead and do your topical TYS topical, right? So that's all for today's lesson, right? I hope you spend your time wisely in class. That's all. Thank you so much and bye bye.